Good morning, everyone. So today we got to start off with this warm-up problems here. I'm going to give you a quick hint before I have you guys pause and try it out. I would recommend drawing a triangle. Then from there, see if you can figure out what the value of x would be for each. So go ahead and pause and take a minute, try it out. Okay, welcome back. Let's take a look at how we do this first problem. So we got triangle ABC. So like I said, let's draw a quick example, triangle ABC. Call this x, 2x, and 3x. So once you got a triangle here and it says find the value of x, basically all it's asking is, well, what does this value of x have to be for that to be a triangle? So to get that, what we need to do is think about what do all the angles of a triangle add up to be. And if you guys remember from that triangle sum theorem we talked about many times, but we also talked about on Friday, these should add up to 180 degrees. So all we need to do is we need to say that x plus 2x plus 3x equals 180. And that's the basic problem. You just got to solve it from there. So if we solve it just real quick, we got like terms here. We got an x, a 2x, and a 3x. Together that makes 6 x's. Ooh, that's a lot. Alright, so 6x equals 180. From there we solve by dividing by 6 on both sides, and we get x is equal to 30 degrees. So all it's going to tell you is this angle A is 30 degrees. This angle here is 2 times 30, or 60 degrees. And this angle here is 3 times 30, or 90 degrees. So we got a 30, a 60, and a 90. Those three should add up to 180. So if you want to check that out, do a little mental math there, see if that works out. Alright, so why don't you guys pause, try number 2, do a quick pause, and come back and take a look at the answer. Okay guys, so for number 2, as you can see the answer there, we got x was 27, using the same method we did in the first problem, where all three of these angles have to add up to 180 degrees. So use that same method, combine your like terms, and solve for x. You get that x equals 27. Then from there, you take the x equals 27 and substitute it in for each of these angles, D, E, and F. And then you get your final answers there for those angles. And that's it. If you want to take a minute and pause to continue checking that out, you can. Go ahead and pause now. Alright, so let's take a look now at what our goals are for today. So goals for today. We've already hit these 4 as of Friday. So now we have 3 more triangle theorems that we need to look at for today. It's called the Midsegment theorem, the Proportionality theorem, and actually we only have 2. The last part we're just going to be practicing with those triangle theorems. So those are our plans for today. So let's take a look at what we're going to do. First thing we're going to do is you guys should have a foldable here that you can cut out. So we got a foldable. It kind of looks like this on one side, and on the other side you got some examples. So what we're going to do with this is you guys will be cutting that out. So cut around that border and then fold along those dotted lines. You want these 2 images here to be on the outside. Okay, so take a minute, get those cut out, pause the video if you need to, and then come on back when you guys are all ready to start taking some notes on these. Okay, so once you open up your foldable, on the inside, we got these 2 theorems. So we need to define what those 2 theorems are before we start. So what you guys need to do is go ahead and pause and get down these 2 things on the top and bottom of that foldable. Go ahead and pause now to get those down. Okay, welcome back. So let's take a look at each of these theorems one at a time, and then we'll take a look at some examples that we got on the page here. So the first thing we're going to look at is the triangle proportionality theorem. What that theorem says is that a line parallel to one side of a triangle divides the other two proportionally. So if we look at our example, let's break down what that actually means. It says a line parallel to one side. So if we look, this line is parallel to one side of the triangle down here, divides the other two sides proportionally. So if you look, this side is divided into two parts, that's 6 and 18. And then also this side is divided into those two parts, 4 and x. So it says it divides them proportionally. So what that means is that we can write a proportion of those corresponding, these corresponding sides. So the way we're going to write that is we're going to set up a quick proportion here where we take the proportional side of each. So we're going to do 6 over 18 is proportional to 4 over x. So we got that proportion. What we're going to do with that proportion is basically we're going to use that proportion to solve for that x value. So to solve that, we're going to cross multiply 6 times x, 18 times 4. Let's look what we get there. We get 6x is equal to 18 times 4, so I believe that is 72. And then from there, we're going to solve for x, so we need to get x by itself by dividing by 6. Cancel there, and we get x is equal to 72 divided by 6, or 12. So we get a final value of x is equal to 12 for that one. So example 2, same theory applies, same theorem, triangle proportionality theorem. Again, what we got to do is find that parallel side. And that parallel side divides the other two sides into two proportional parts. Top over bottom there, and top over bottom there. So all we need to do is we look at our proportional parts and we set up some ratios. So all we're going to do is set up those ratios. We'll do that 12, and we're going to put that over the same side that it's on. So if you look, that parallel line kind of makes the fraction for you. We're going to write 12 over x minus 10. And then we're going to write is equal to, and notice this order, I did the 12 first, so I'm going to come down here and do the 8. 8 over 6. Now all we're going to do from here again is we're going to cross multiply. I'm going to run out of room on my picture, so I'm going to bring this problem over here once I cross multiply. So we're going to do 12 times 6, 8 times x minus 10. So let's do this big part here, this 8 times x minus 10. When I write that, the way I want to do it is I'm going to say this. I'm going to say 8 times the quantity of x minus 10. Notice I'm putting that in parentheses because when I multiply by a binomial, I want to make sure that I'm going to multiply that number by the whole binomial and not just that first part, x. So we got that piece. And then the next piece is 12 times x. And 12 times 6 is going to give you that 72. Now from here, all we're going to do is solve for x. So we're going to distribute our 8. 8 times x is 8x. 8 times negative 10, negative 80. And that's going to equal to 72. Now from here, what we're going to do is we're going to solve for x. So add 80 to both sides to get that x by itself. On this side they cancel, so we're left with 8x. On this side we get 152. And then from there we're going to divide both sides by 8 to again get that x by itself. So then x is going to equal 152 divided by 8, which should give you 19. And that's how you do those problems. So again, quick recap. All we're doing is we're seeing that parallel side and saying, okay, it breaks it into two proportional parts. And so I'm going to write those parts in a proportion. From there, you do the same proportion on the other side for the other side of the triangle. And that's it. Cross multiply and solve. All right, so that's the triangle proportionality theorem. All right, so our next theorem we want to look at is this midsegment of a triangle. So this theorem is kind of a simple topic, but it's something that we definitely need to talk about. So what the midsegment theorem says is that if I take a line that cuts both or two pairs of the sides of a triangle into half, so basically it's cutting both sides of that triangle in half, so we're hitting the midpoint on both sides, then I have a line called the midsegment. And when you have that midsegment, what happens is this line is going to be parallel to that third side of the triangle, the side it's not cutting in half. And then also the special property happens where if this is parallel and it's making the midsegment of both of those sides, then the midsegment is half the length of the parallel side. So that was rule 2 there. Midsegment's half the length of the parallel side. So what that means is that I can write an equation that says 2 times whatever this midsegment is equal to that parallel side. So I can say that 2 times my midsegment in this case is x. Well, let's write that in there. It'd be a good idea. This is your midsegment. So 2 times that midsegment, which we know is x, is equal to that parallel side, 18. So then from there, all we would do, because twice the midsegment is equal to that parallel side, is say 2 is solve this equation, 2x equals 18. So to solve this, we're going to divide by 2 on both sides, get x by itself, and x should equal 9. So that's the first one, that's the first example. So we look at example 2, same concept applies, but if you look, let's identify our midsegment and parallel side. Midsegment's going to be this line here. That's our midsegment. And then our parallel side would be that side. So our equation says that 2 times the midsegment, and notice how I'm putting this value in parentheses. Anytime I substitute, I really like to use parentheses because then I know I'm not missing anything in my equation. So 2 times the midsegment is equal to that parallel side. So this equation, we just got to solve for y. Y is already by itself, so we just need to simplify this side. So we should get that 24 is equal to our parallel side y. So the equation works the same way every time. You just do 2 times the midsegment equals the parallel side. Alright, so we have our 2 different theorems down that we need to learn today. So now what we need to do is get some practice with them. Okay, so here's some examples. So what we're going to do is take a look at the examples, take about maybe 10-15 minutes, try out these 4 examples, give it an attempt, and then when you come back, you can take a look at the answers and we'll talk about a couple of them. So go ahead and pause now and try out these problems. Alright guys, so here's the answers you should have gotten for each of these problems. So take a look, see if you got those answers. If not, we're going to take a look at each of them and talk about how I would set up the problems and how I would solve them from there. So let's go ahead and jump in. For number 1, we should have got x equals 20. Let's talk about how we would do that. So what we're going to do is, again, if you look, we have to know what theorem to use. In this problem, all we know is that this is a parallel side. So we got that parallel side there. That means we're going to have proportions where that parallel side basically makes 2 fractions for us. So our 2 fractions are going to be this. X over 10. See how that parallel side makes that fraction? Is equal to 8 over 4. From there you just cross multiply and solve. 10 times 8, 80. 4 times x equals 4x. Solve this equation. We're going to get x by itself, so we're going to divide by 4 on both sides. Now x is by itself. 80 divided by 4 gives us that answer of x is equal to 20. So that's the first one. So we're going to do the same thing, taking a look at number 2. We have to look at what is the property shown here. So if we look, obviously it's not a midsegment because 8 and 10 are not equal to each other, but we do have those parallel sides. So you remember, if we have parallel sides, that one inside parallel side makes a fraction for us, and we just got to write that fraction. So we're going to say x over 5 is over 15, sorry, x minus 5 over 15 is equal to 8 over 10. And from there, guys, all you got to do, cross multiply and solve. So with this one, you got to be careful when we're multiplying, cross multiplying using this binomial. I want to make sure to put that in parentheses. So I'm going to say 10 times the quantity of x minus 5 is equal to 8 times 15, which is 120. Now from there, to solve this, we're going to distribute the 10. We get 10x minus 50 is equal to 120. And then we're going to go and solve for x. So we're going to get x by itself. So let's get rid of this negative 50 by adding it to both sides. Cancels on that side, left with 10x. Oh, not 18x, but 10x. And 120 plus 50 gives us 170. Then from there, get x by itself. 10 is times x, so we're going to divide by 10. Cancels there. We get x is equal to 17. All right, those two are pretty straightforward. Remember, with just knowing this is a parallel side, then that parallel side makes that fraction. So there are two fractions, 8 over 10, x minus 5 over 15. All right, so that is the proportionality theorem. Now we're going to take a look at 3 and 4. Those two, what we want to do is we want to solve for x again. To do that, we're going to find out what theorem we need to use. So if you look, see how this line here makes two congruent lines there and two congruent parts here. So that means this must be a midsegment. So if that's a midsegment, then what we got to do is reference back to our foldable and say, okay, well, that theorem that they gave us, that equation says 2 times the midsegment is equal to that parallel side. So all we need to do is substitute our values for that equation. So we're going to do 2 times our midsegment, in this case 4, is equal to our parallel side, 5x minus 2. So we do that one. We're going to solve for x. So first off, let's simplify each side of the equation what we can. 2 times 4 is 8. This side can't combine anything, so let's just bring it down. Now we're going to solve for x. So to get x by itself, I got to get rid of that minus 2 by adding it. Bring down what I got left. And then to get rid of this times 5, I'm going to divide by it. Cancel out the 5's there. We get x is equal to 2. And that's it. All right. So number 4. This one is a couple different problems because it says find the value of each of those variables. So we got to find what x, y, and z are. So let's just pick one variable at a time. Let's go ahead, let's do alphabetic order. So let's start with x. So we look, x is this line here. And if you see that x line cuts these two sides into two congruent parts. So that means it is a midsegment. And since it's a midsegment, we can use that equation. 2 times the midsegment equals the parallel side. So what we're going to say is 2 times our midsegment x is equal to its parallel side. So what we have to do is figure out what side is parallel to that side. So basically which one's going the same direction. So obviously it can't be these two sides because it goes through those two sides. Those sides will not be parallel. But if you look, this side here is going to be parallel to it. So this side is parallel to it. So what that means is 2 times x has to equal 24. So what that tells us is now we have an equation for x. So we can solve for x by dividing by 2 on both sides and get that the x variable is equal to 12. So that's x. Check. All right, now we got to do z. So I'm skipping y because that one actually doesn't have anything to do with triangles, and we'll talk about it when we get to it. But let's look at z first. So z is marking this part of that side. So it's not marking the whole side, it's just marking that part. But we don't know how to find anything about parts, so what we're going to do is we're going to look at, well, what would this whole side be? And if I know this whole side, I'm going to figure out what z is from there. So this is a side of the triangle, and I know with my midsegment theorem that if I can find the midsegment to this side, then 2 times the midsegment will equal that side. So basically I got to find a side parallel to this one. So it can't be either of these two sides, because again those cross the side I want to find. The only line that would work in this picture would be that one. And if you look, it is a midsegment because it divides these two sides into 2 equal parts. So the midsegment is 11, and this whole side is going to be twice that. So to find that, we're going to say 2 times 11. Well, that's going to equal to that side that we marked out here, 22. So now, if this whole side is 22, and z is half of that whole side, z must be 11. So z is 11. Okay? So we got z to be 11. We got x to be 12. Now we have to talk about this y. How did I get 133 for this angle here, y? So if you look, this problem is actually pulling in some stuff that we learned a little bit ago, and this actually isn't even on your paper. But if you look at this shape that the y is in, wouldn't that have to be a parallelogram there? Because midsegments are parallel to the opposite side. So we have a parallelogram. What do you guys remember about consecutive angles and parallelograms? Remember, these two angles have to be supplementary. So basically we just have to say they add up to 180, and then we can solve for y. So we're going to say, because they're supplementary, they add up to 180, because that's what consecutive angles do in parallelograms, if you guys remember those parallelogram properties. So we're going to solve by subtracting 47 from both sides. We're going to get y is equal to 180 minus 47, which is 133. So that's our final answer there for y. Alright guys, so that's some good practice for these problems. You can take those and glue those into your notebook so you have them as good example notes. So go ahead and pause the video if you didn't get all that down. Take a minute to get all that down, make sure you understand it. And then what we're going to do is look at a couple recap questions. So go ahead and pause now if needed. Alright, so let's recap these problems here. So with each one of these, I want you to just take a minute, read through the problem. Always, always, always word problem, draw a picture. So draw a picture for this first one, see if you can figure out what it's asking you to find, and then take a look at number 2. Think about what theorem you would need to use, write an equation, and solve it. So take a couple minutes, maybe 5-10 minutes, try out these 2 problems, pause the video, and then come back and we will check them out. Okay, so let's take a look at each of these problems. Hopefully you guys were able to solve or at least get them set up. So let's take a look. This first problem, we have 2 ladders leaning against a wall such that they are parallel with each other. So let's draw a quick sketch of that. We got a wall here, and we got 2 ladders. Let's say we got a blue ladder and we got a green ladder. Those 2 ladders are leaning against a wall, like so. And put in a floor there for our ladders to be on so they weren't just floating in the middle of nowhere. So we got our 2 ladders. Next sentence. The shorter ladder's feet are 12 feet from the wall. So this shorter ladder is 12 feet from the wall, and it reaches 8 feet up the wall. So up the wall, it's going to be 8 feet. So we got those 2 values. Now let's take a look as we go on. It says the taller ladder's feet are 15 feet from the wall. Okay, so we got to be careful here though, because what I would want to do is just write 15 right here. But the problem is that 15 right there would just mark the distance between the two ladders. It's saying that the distance from the wall to that blue ladder is 15 feet. So this whole distance is going to be that 15. So we have to be careful there. So we got that, that's 15. And then it says, how much further up the wall does the taller ladder reach? So what they're asking is how much further up is this ladder going to reach? So they're asking what is that value there, that x value, the distance between the green ladder and the blue ladder. So to figure this out, if you guys remember, it said that the two ladders were parallel to each other. So if you look, what we have here is that proportionality theorem when we have a side parallel to another side in a triangle. See, isn't that nice how math works out? So what we're going to do is we're going to figure out what that x value needs to be by using that proportionality theorem. So if you guys remember that proportionality theorem, that parallel side made our proportions. So if we look, we got 8 and x, so we're going to write those proportions. We'll say x over 8. So we get that. So that's going to be equal to these proportions here. Now, we got x over 8 there, but if you look down here, we have the 12 that would correspond to the 8, so we can put that in. But what we have is we have this whole distance from here to here. We don't have the distance from here to here, which is what the x would correspond to. So what we need to do is we need to figure out what that distance would be. So if we look, 15 is that whole distance, and 12 is the piece from here to here. So what's left out of that 15, if I already used 12, is just 15 minus 12. Oops, that was weird. 15 minus 12, or a final answer, 3. So this piece must be 3. So now that we have the right number, let's put that in a proportion. From here, we just cross multiply and solve. X times 12, 8 times 3. We get 12x is equal to 24. Solve for x by dividing both sides by 12. Cancel out that times 12. X is then equal to 24 divided by 12, or 2. So the ladder officially reaches up 2 more feet. 2 more feet. And that's it. Alright, so word problem's not too bad as long as you can draw a picture of the situation. You just take the words and make a picture out of it. Alright, let me erase some of this extra writing that we did here. Let's take a look at the second one. Now this second one should be a little quicker to do. Let's take a quick look. What you want to do for every problem is identify what theorem do you need to use. What property can you use here? So if we look, these are the two sides that are labeled. So we need to figure out, well, how can those two sides relate? So if you look, this side here, this 11, it's making the two sides it cuts be cut in half. So it's making two congruent parts out of those two sides. So what that means is this has to be a midsegment. So we've determined that's a midsegment and that this side is going to be its parallel side. So what that means is we have to use that equation. 2 times the midsegment is equal to that parallel side. From here, it's just substituting your values, solving for x. So 2 times our midsegment, which we said was 11, is equal to that parallel side, which it says is 3x minus 5. Right in parallel here. So realize now it looks like an 11. So 2 times 11 equals 3x minus 5. Solve that equation. 2 times 11, 22, is equal to 3x minus 5. Solve for x by adding 5 to both sides. Cancels out there. Bring down your 3x. Now x is times 3, so to cancel that out, divide by 3, we get 9 is equal to x. And that's it, guys. So that's really all there is to the triangle proportionality theorem, and midsegment theorem. Alright, so now what I want you guys to do is there should be a review there for you guys to get started on. So this review is going to be good practice for your upcoming test on constructions and triangle theorems. So anything on this review could and probably will be on your test coming up. So what I need you guys to do is start working on that review so that we can get it done and we can go over it tomorrow to make sure that you know how to answer all the questions and you can be successful on the test. So go ahead and get started on that review and we will talk about it tomorrow. Have a great day, guys.